Hello everyone. I welcome you all to this another video of daily Leetcode problem solving. So let's see today's problem. So we have been given a binary string s, an integer k, and we need to return true if every binary code of length k is a substring of s. Okay, if it is not, then we need to return false. What does this mean? Given a binary string s and the integer k. So first of all, we need to see what is this binary code of length k. So if the given value of k is 2, so whatever the binary codes of length 2 can be created. So what are the different binary codes which we can create of length 2? So the length will be 2, and binary code means we can fill this position either by 0 or by 1, either by 0 or by 1. So this is a binary code. So we have either I can fill here 0, and then I can put here 0 as well. Either, or I can put here 0 and here 1, or I can do 1 0, or I can do 1 1. So there will be 4 different binary strings which can present of length 2. Okay, no other binary code can present of length 2 other than these 4. Okay, so we have two choices at the first position and we have another two choice at the second position. So there will be total of 4 binary codes which will be present. So in general, if the length is k, each position can be filled with two choices. So the total number of binary codes which can be created will be 2 raised to the power k. Okay, okay, that is fine. And also observe here that the binary code, if I see the number corresponding to this binary code, this will be 0. The decimal number corresponding to this binary code will be 1. The decimal number corresponding to this binary code is 2, and for this binary code it is 3, right? Because this bit has a weight of 1, this bit has a weight of 2. So these are the different numbers, decimal numbers present. If the length of the, if the value of k is 2, the different decimal number which I can get will be 0 1 2 3. Okay, and these are the binary codes present corresponding to these numbers. So I need to check if all these codes present in the given s or not. Let's say in this example, the s is 0 1 0 0 1 1 0 1 1 0. So check if this present or not. 0 0, yes, this present. 0 1, yes, 0 1 is also present. 1 0, yes, 1 0 is here. 1 1, yes, 1 1 1 is here. So all these 4 binary codes are present in this string s. So I will return true. But let's say this was, let's say this was also 0, and this was also 0. So I have 0 0, I have 0 1, I have 1 0, but I do not have 1 1. In that case, I will be returning false, right? So how can we solve this problem? So one of the choice can be, what I will do, let's say I have this k, right? I will generate all the different binary codes which can be generated of length k. Okay, so let's say the given value of k was 2. So the first code which we can generate will be, let's first of all, let's see how many total codes which we can generate. This will be 4, 2 raised to the power 2, right? So the first code will be correspond to the 0 decimal number, and the binary code will be 0 0. So I will check if this binary code is present in the given string or not. So given string was 0 0 1 1 0 1 1 0. So yes, this is present. So I'll go ahead, check the next binary code. So the next decimal number will be after 0 will be 1. And the binary code corresponding to this number will be 0 1. And I'll again check if 0 1 is present here or not. So yes, 0 1 is here. Okay. I'll go ahead, check the next number. This is 2. The binary code will be 1 0. I will check if this 1 0 is present here or not. Yes, this is present. Okay, fine. Go ahead, check the next number. The next is decimal number is 3, and the binary code is 1 1. So 1 1 1 1 1 is also present here. Okay, and just come here back. So now we need not to check the other number because I have already checked the 4 binary codes. Okay, so the moment I've checked all the binary codes and everyone was present, I'll return true. But let's say the string did not have 1 1. Okay, this was something like this. I could have, I will be getting 0 0, yes. I'll be getting 0 1, yes. Go ahead. I'll be getting 1 0 as well. This. Okay, go ahead. Check for this. Now I need to check for 1 1. I'll check. No, 1 1 is not present here. So when I will check the that 1 1 is not present here, at that moment only I'll return false. Okay. Or take another example. Let's say the string was 0 0 1 1. This was the string, right? So I'll check here for 0 0. Yes, 0 0 is present. Check for 0 1. Yes, 0 1 is also there. Check for 1 0. I could not find 1 0. So I will not go after this. And from this point only, I'll return false. Because I found a string that I found a binary code whose corresponding substring is not there in the given string s. Okay, only that moment I'll return false. And let's see what is the time complexity if we try to solve this problem using this algorithm. So what I'm doing, I will be enumerating all the different binary codes possible of a given length. So there will be 2 raised to the power k binary codes, total binary codes possible. And for each binary code, what I'm doing, I'm checking that binary code in the given string s. So in checking whether the given binary code is present in the string s or not, the complexity will go up to the length of the given string, right? In the worst case, I'll have to iterate over all the till the last of the string to search for the given binary code. So 2 raised to the power k into length of string. This will be the time complexity of this algorithm. And let's see what are the number of computations we will be doing if I write this algorithm. So the 2 raised to the power k, the worst value of k can go up to 20, 2 raised to the power 20, and the length of string can go up to 5 into 10 raised to the power 5. So 2 raised to the power 20 has a value of order 10 to 10 raised to the power 6. Not exactly 10 raised to the power 6, but it is in the order of 10 raised to the power 6, and 5 into 10 raised to the power 5. So this will be coming out to be 5 into 10 raised to the power 11. So these many number of computations I might do if I write this algorithm, and this is not going to be accepted because I'm doing 10 raised to the power 11 computations, which is too large computation. So actually the solution where the number of computations are limited up to 10 raised to the power 9 are get accepted. But here the number of computations are 10 raised to the power 11. So this solution will not be accepted. So we need to think something else here. So let's see what the other thing which we can think of. Uh, what thing if I can do something here, like I'm searching again and again in the string. If I can reduce this computation, I'll be drastically reducing my time complexity. What I'm doing, I'm searching each and every string there. Instead of that, I have to do something else. I don't want to search every time the string. Okay, so we can do one thing here. We know that for the given k, I am checking what is the order in which I'm checking. First of all, I'm checking the binary string correspond to the binary code correspond to 0 is 0 0, and I find that if this is present there or not. Then if that is present, I go to the next number, decimal number, which is 1, and the binary code is 0 1. Then I check if this binary code is there or not. Okay, then if it is there, I go ahead. If it is not there, I simply return false. Then I'll check for the next number 2, and the binary code corresponding to this number is 1 0. And I'll check if this is there in my S or not. If it is there, I go to the next number, and so on up till I have hit all the binary numbers which can be possible of length k, right? So what I can do here, these numbers are sequential, right? So if let's say the value of k was 2, so the different possible binary numbers can be 4, and they're 2 raised to the power 2, which is 4. Different binary numbers will be 4. So it will be 0 1 2 3, 0 0 0 1 1 0 1 1. Okay, so these are nothing but if I create an array of size 4. So the first index will be 0, second index will 1, then this index will be 2, this index will be 3. Okay, so I can see that if I create an array of size 4, so all these numbers are just the index of this array. And I will say that if this array, if there is some index I of this array is true, that means that decimal number, the binary code present to this decimal number is present in my S. What I am saying? I'm saying, let's say the S was 0, 0, 1, 1, 0, 1, 0. This was my given S, and the K was 2. So the different binary numbers can be 0, 0, 0, 1, 1, 0, 1, 1. These are different binary codes, and the decimal number corresponding to these numbers will be 0, 1, 2, and 3. So what I will do, I'll first check for the 0. I'll check if the binary code present. Okay, so what initially I was doing, I was checking if binary code corresponding to this number is present there or not. Binary code corresponding to this number is present there or not. Instead of doing that, what I can do, this is my given S. I will iterate on this S, starting from the first index. I will choose a substring of length k. So here the k is 2. So starting from here, the substring will be this. So this substring, I'll check what is the decimal number corresponding to this substring. So this is 0, 0. That means the decimal number is 0. So I will go to the 0th index of this array, which I have already created of size 2 raised to the power k. I will mark it as true. Yes, this the binary code corresponding to this decimal number is present in my given string. I'll mark it true. Then I'll move to the next index, and then I'll check for the again a substring of length 2. So this is a substring of length 2. So this is 0, 1. Okay, so corresponding to this binary code, the decimal number is 1. So I'll go to the this array again, corresponding to the decimal number 1. I'll mark it as true again. Then I'll move forward. Then again the substring of length k, which is 2. This is the substring. So the decimal number corresponding to this substring will be 3, right? So I'll go to the third index, mark it as true. Yes, this substring is there. And then I'll again move forward and I'll check what is the decimal number corresponding to this substring. So this is nothing but 2. I'll go to the second index, mark it as 2. So in this way, I will iterate on the all the substring of size 2 in this string. Okay, so I have iterated over all the substring. You can check this. So all the substring will have a particular decimal value, and I go to that decimal value and mark that index true. When I have gone to all the substring of length k, I have what I will do, I'll visit this array again and I'll check if the this binary code is present there or not. If this binary code was present there, then I would have marked this as true. Okay, this is true. Okay, move forward. This is also true. That means the binary code corresponding to this decimal number was present in my S. That is why this was marked as true. Go ahead, go ahead. And when I hit the end of the array, that means that I have not met with any of the you can say the abnormality. There's none of the decimal number which was missing. That means this is a success. I've got all the decimal. I've got all the decimal numbers. That means there are all the binary codes present of this length in the given string. So I'll return true. But let's say there was a string s which was 0. Let's say this was s1, this is s2. Let's say this was 0, 0, 1, 1, and 0, right? So again, I'll go here, go at the 0th index. Let's say this is the array 0, 1, 2, and 3. I'll go here, check this. So this corresponds to the 0 decimal number. I'll go here, mark it as true. Go to this string, substring. This is correspond to 1. I'll mark it as true. This is 3. Mark it as true. Okay, again I've enumerated all. Let's say the example is 0, 0, 1, 1. So I'll mark 0, I'll mark 1, I'll mark 3. So I've come to the end of the string. So this was already there false. So this has not been converted to true because there was no substring whose decimal value is 2. So when I hit the end of the string, I'll again revisit this array. I'll come here. So this is true, I'll move forward. This is also true, I'll move forward. This is false. That means the binary code corresponding to this decimal number was not there in this string. So that means, but it should have been there. So that means it do not contains all the binary encodings of length k. So at that moment only I'll return false. I'll not go forward. So if we solve this problem in this way, what will be the time complexity? So what I'm doing, I'm iterating over the array. So iterating over the array, which is the length of string. And while iterating, I'm just extracting a substring of length k. So in every iteration, I will be taking the k amount of time to extract that substring. Here I'll take k time, then here I will take k time, then again here I will take the k time, then here I'll take the k time. So in this way, the complexity will be this one. Okay. And again, not only doing this, I will also get the binary number corresponding to this string, which will again give complexity of order k. So I'm iterating over the string, and while iterating, I will be creating the substring, and then I will check the binary value of that substring. So the total time will be k plus k. So the complexity will be length. If I say L is the length, and this will be 2 into k. So asymptotically it is equal to L into k. The complexity will be this. And what I'm doing, I will just marking that index true, and that is an order one operation. So this will be the overall complexity. So if we see what was the constraint, the length can go up to 5 into 10 raised to the power 5, and the value of can go up to 20 in the worst case. So in the worst case, the number of computations I will have to do will be 5 into 2 is 10 into 10 raised to the power 6, which is 10 raised to the power 7 computations, right? Which is acceptable. And then I will revisit this array which I had created to check if there is some decimal number which is not present there. So the size of this array can go up to 2 raised to the power k, which is in the worst case, the k value of k will be 20, 2 raised to the power 20, which is in the order of 10 raised to the power 6. So again, the number of operations I have to do will be 10 raised to the power 6. So the total number of operations will be 10 raised to the power 7 plus 10 raised to the power 6. Okay, these are parallel operations. First I'll finish this operation, then I'll start this operation and finish of this. So this is bounded by order of 10 raised to the power 7 operations. So this solution should be accepted. So let us try to code this and understand more. So what I was doing, so let's say the total number of string which I can create is using k. If the value of k is, if I have been given the value k, so number of total number of binary codes which I can create is 2 raised to the power 6, 2 raised to the power k, right? So either I say that this n is the total number of binary strings which I can create, right? So to calculate the value of this, either I will do power of 2 comma k, or there is also a smart trick what I can do. I will say I'll just shift this number 1. I'll shift the number 1 towards left with k number of shifts. So what this will do, if the value of k is 0, the number this will not be shifted. The binary representation of 1 is this. This will not be shifted even a single from a single position. Okay, if the value was 0, so the value will be 1. That means the total number of strings which I can create is 1 only. Okay, if the k is 0, if the k was 1, this will be shifted by 1. Okay, here, and this will be 0. So the binary value will be 2. Okay, so this is nothing but this is 2 raised to the power 1, which is 2. If the value of k was 2, then this one was shifted by 2 position, in the first move here, in the second move here. Okay, so this is nothing but 4 in binary. So 2 raised to the power 2, I've calculated 4. by just shifting one with the 2 position. Okay, and initially it was 2 raised to power 0, which was 1. Okay, so in this way I can calculate the power by just shifting 1 towards its left. Shifting towards means I'm just multiplying the number by 2. Okay, so initially the number was 1. If I shift by 1, multiply by 1. If I shift by 2, again multiply by 2. If I shift by 3, again multiply by 2. If I shift by 4, again multiply by 2. So if I have done 4 shift operation, I have actually calculated 2 raised to the power 4. Okay, so the number of substrings will be 1 left shift k, right? And then I need to create an array of size. The size of the array will be n again. Why? Because there will be n different substring. So corresponding to each index, I will be marking true or false, 0, 1, and this up till 2 raised to the power k, right? So I've created this array as well. Now what I am going to do now, what I was doing, I was iterating over the array. So for int I equals to 0, and till what position I need to iterate. Let's see this. If the string length was 2, if the string length, let's say this was the string 0, 0, 1, 0, 1, 1, 0, 1. If this string was this, and the length of my, if the value of k is 2, that means I will be checking all the binary string of length 2. So I'll check this binary string, I'll check this, I'll check this will be the last index. I'll not go beyond this index, because if I go beyond this index, I will not be able to find a substring of length 2. So I will have to stop here. So the condition will be I plus k should be less than equals to what, as dot, the length of the string, right? Because here in this example, initially the value of I was 0. The length of this string is 1, 2, 3, 4, 5, 6, 7, 8, right? If I'm at index 0, I'll take an string of length 2, 0 plus 2. I'll take this substring from 0 to 2. Then I'll move here. Then I'll take this string. If so 0, 1, 2, 3, 4, 5, 6, 7. If I am at this index, sixth index, I will take 6. I'll check 6 plus 2, which is 8, which is less than equals to 8. So I will take this substring. Then I'll move ahead. This will be 7. Then I'll check 7 plus 2, which is 9, but which is not less than equals to 8. So the condition will violate, and I will not go beyond this position. Okay, so this should be the condition. Now what I'm going to do, I'll take the substring, right? I'll take the substring from this position of length k. I can pass I plus k, which means if I am at 0, take the substring from index 0 to 2. So this is not included, this is included. So the substring will be 0, 1, and the second index will not be included. So substring will be 0, 0, 0. If I'm at index 1, I'll do 1 and then 1 plus 2. Why 1 plus 2? Because starting position was 1, and from here the length was 2. So the final index should be 3. So final index should be 3. So the string will be, it will take the first position. It will take this character, it will take this character, but this will not take this character because last one is excluded. So the string will be this one, 0, 1, right? I'll do this, and corresponding to this, I've got this substring, right? I've got this substring. I need to get the binary value. This is actually binary for me. I'll get the decimal value corresponding to this. So either I can write a function to calculate the decimal value corresponding to a given binary, okay? Or I can also use the inbuilt function. In Java, we have integer dot value of, I'll get the value of this substring, and I will also need to pass its base, which is base 2, because this is a binary string, this has a base of 2. So I'll get the decimal value corresponding to this value, right? And then in the array to this index, I'll go and mark it as true, right? So this index is present there, that means. And then I will be checking for the entire array. I'll revisit the array from the 0th index till the last position, and I will see if this array of I is false, then I'll simply return false, because that that binary code corresponding to this ith decimal number is not there. Or if none of the this condition was never met true, that means all the indices were true, so I'll come out of the loop and I'll return true. Let's check this on the sample test cases. Okay, this typo should be integer. Again, it is saying, okay, I have taken this as integer array. It should be a Boolean array. Okay, this is working fine. I can also check on larger input. It should work fine. Let's take one few examples. If I say the string of length 1, if I say this of length 2, if I say 0011 of length 1. Okay, let's see. Okay, it is working fine. So let's submit the solution. Okay, the solution has got accepted. Fine. So I hope you understood the concept, and if you have any doubt, then you can comment this, and if you have some better approach, you can also mention them in the comments. And if you have you can connect with me on my LinkedIn. I've mentioned my LinkedIn profile in the description. So see you again in the next video.